Okay, guys, what if we're trying to use projectile motion to figure out whether something will make it? So let's start here with a bank. We've got a river bank here and another river bank on this side. Okay, so we've got those two river banks, and this is a river, so there's water down here. It's white water. All right, so we have a person standing, and she is going to run, or he, it doesn't matter. He is going to run off of the cliff at some speed. We'll say her speed is, it's a her. There we go. Okay. So the Vx would be 7 meters per second, let's say. And let's say that she successfully makes it to the other side to keep running. Okay, so she successfully makes it to the other side to continue her running, and nothing went wrong in the process. All right, the river is an unknown distance across, but we know that the difference in heights between here and here, the difference in height is, let's say, 3 meters. Okay, so the difference in height between bank A and bank B is 3 meters. Well, what would we do in order to figure out this distance in the x? Well, if you'll remember, I told you that if you don't have the time, you almost always need to solve for the time. So in this case, we have this number right here that will allow us to solve for the time, because this is equal to the distance in the y. And if you have the distance in the y, especially with a horizontal projectile, you can always find the time. So we're going to come to this page. If something falls 3 meters, we know we can solve for time, because the distance in the y is equal to 1/2 acceleration in the y plus, times, let me erase that and start over. Alright, so dy is equal to 1/2 ay t squared plus biy times t. And if you'll remember, in a situation like this, where it's a horizontal velocity, the initial velocity in the y is equal to 0. So this goes to 0, which means it cancels out, and we don't have to worry about it anymore. So we're left with 3 meters equals 1/2 times -10 times t squared. And if you'll remember, since it's falling 3 meters, since she will fall 3 meters, we have to make that negative as well. So we end up getting -3 divided by -5 square rooted, because 1/2 times 10 is -5, equals t. Because the t is squared, we have to do the square root. Alright? So let's figure out what that is. So if we square root 3 divided by 5, we get 0.77 seconds. So we know that the river, it took her 0.77 seconds to get across the river, because it took her 0.7 seconds to fall the 3 meters, and since the river, since she only had 3 meters to fall, we know that it also took her 0.77 seconds to cross it in the x direction as well. So we now have a time for the distance in the x. We have a velocity in the x. If you'll remember your formula for the velocity in the x is equal to the distance in the x divided by time, and the time is 0.77 seconds divided by dx, and the velocity in the x was 7 meters per second. So we get equals 7 meters per second. So 7 meters, we have to multiply both sides by 0.77. And if we do that, we get Vx, not Vx, we solve for dx. So we get dx equals 5.39 meters. So the river that we crossed, or she crossed just then, was 5.39 meters. And we had to do two things in order to answer this problem. We had to first figure out that since the distance in the y was 3 meters, we had to use this information to find the time, and then once we got the time, we could solve for the distance and the x. Alright? So, hope this helps you out, and have a good day.